I'm Rick Magenti. I work for the division of toll bridge design, and I'm going to talk about what we call green concrete. The reason we call it green is because it's environmentally friendly. How is it environmentally friendly? It has to do with the production of cement. Cement is the ingredient that makes the concrete a rock. And producing cement, there's a lot of energy in producing the cement. So any way you can reduce the cement, you're reducing greenhouse gases because you're not using as much or producing as much. Approximately, it's on a one-to-one basis. 1 ton of cement equals 1 ton of CO2 that goes to the atmosphere. How did we reduce the cement? It was reduced with what's called in the industry supplementary cementitious materials. They're byproducts of something else. In the case of the Bay Bridge, it was mostly slag. Slag's a byproduct from the steel industry, and fly ash is a product from coal-powered power plants. We used quite a bit of those ingredients on the new east spans of San Francisco-Oakland Bay Bridge. Incidentally, we first used it, we didn't have in mind the environmental effects. It was used because these materials give certain qualities to the concrete. Some of the qualities we were looking for was durability. The bridge was a 150-year design. They're recycled products or waste products, and so they're cheaper than cement, and so they actually help with the cost. It had other benefits, which was why we used them. It lowers the heat of the concrete as it's curing. That can be a problem at times. We had some pretty big elements out there on the bridge, so controlling the temperature as the concrete was hardened was an important thing. As it turned out, after the Skyway was done, which was the concrete structure, there's a legislative bill, AB 32, which was the Global Warming Solutions Act. Part of that act, Caltrans was tasked with lowering cement in our structures, and we had already done that for probably more than half of the San Francisco Bay Bridge. So when we got to the later portions of the bridge, what we call the Y-bits, which is the Yerba Buena Island transition structure, that's the part that goes from the tunnel, meets up with the self-anchored suspension bridge, like I said. So as it turned out, because we weren't interested, or that wasn't our goal for environmental concerns in using these SEMs, what it showed beyond a shadow of a doubt was that we got a higher quality, a lower cost product that was environmentally friendly, as it turned out on the later part of the bridge as we were complying with the AB 32. Because we had poured so much concrete with this before AB 32, when Caltrans was tasked with it, the task force could use our real experiences out there to write the new standards, which looked a lot like our toll bridge specifications. And we went statewide with what we had implemented back in 1999 up through. So when we started out, we used SEMs intentionally to improve the quality of the concrete, its durability, the strength requirements, and other construction requirements there. And as a side benefit, we used a waste product, and we reduced greenhouse gases, and the whole thing cost less. For the latter parts of the bridges, we used the SEMs to reduce the greenhouse gases per the requirements of AB 32. We used up a waste product. The public is benefiting from not only just the reduction in greenhouse gas, but also a higher quality product. And as a side benefit, we had the high quality concrete needed for 21st century bridges.